Thank you. I'm Michael from Modular Photonics. We are a technology-based company providing hardware systems that plug directly into the optic fibre backbone that will, in essence, help the internet grow. So, as we heard from Flavia's talk, data is growing at an unprecedented rate, driven no small part to our thirst for mobile data, coupled with the emerging Internet of Things. And this has been well popularised in the global media. What is less well known is that there is a looming data crunch that's coming. There's dramatic headlines such as this saying that the internet could actually collapse by 2023. What underpins those sort of claims is the fact that there is an upper limit to the amount of data that optical fibre can actually support, as shown in the red line here. And for the first time in history, the growth in data is actually outpacing technological improvements in the conventional fibre networks. And this is where we come in. So IT providers around the world are not idle in this space. They are developing new fibres and new end-of-fibre components that actually break through that barrier. And we are indeed playing this space as well. So we're exploiting unique optical designs that are enabled by 3D fabrication techniques, as shown here in this cover shot that highlighted some of our work many years ago. We actually use lasers to actually write three-dimensional optical circuits inside a block of glass. And on the right-hand side, you can actually see one of those chips with those thin lines threading from left to right. The optical circuits are actually inside that block of glass. And the three-dimensionality of our fabrication technique means we actually come up with designs that actually can target the issues that actually cause that barrier for our fibre optic networks. So we use this as a platform to explore a range of different business opportunities in the IT space. So for many, many years now, as a test market exercise, we've been selling the research sector, largely to large telco companies such as NTT in Japan, for actually developing next generation networks to actually avoid that data capacity crunch from occurring in the first place. The same techniques and solutions we're applying there, we found will actually have utility in other sectors as well, such as cybersecurity and cable density, which is a big problem in data centres. We have a new product line we'll be releasing there early next year. But it's our MVP that I want to focus on here, because our MVP is a retrofit device that solves the current capacity issue experienced by our data centres in the local area and the public and enterprise networks. This is a $100 million market in Australia, and indeed the market is estimated over $1 billion worldwide. To enable our MVP, we drew heavily on the local ecosystem. So we benefit from seed funding from a host institution, Macquarie University, as well as Jobs for New South Wales, and currently in discussions with the Advanced Manufacturing Growth Centre to actually adapt our MVP to the mining sector. The CSIRO program has been instrumental to the development of our MVP, and we continue to benefit from the runway services that the CSIRO program offers. And we can also get the draw on the prototyping capabilities that are supported by the NCRIS Commonwealth Government Initiative, in this case by the Australian National Fabrication Facility, that's also supported by New South Wales Trade and Investment. And in particular, lets us actually develop prototypes in a risk-free fashion and develop a roadmap for scalable production. So it's actually a great time to be doing hardware in Australia. So our MVP targets legacy fibre networks that represents 2/3 of all optical fibre that's out there. If you pull all that fibre back to back, to actually expand the distance between Earth and the Moon 70 times. Now that legacy multi-mode fibre actually has a problem. It is actually limited the amount of data you can actually transmit over long distances. So 1G, which is the standard for data, video, and voice over fibre, is limited to lengths of 300 metres in that legacy multi-mode fibre. So IT managers of business networks and indeed data centres have no choice up to this point of time, but to recable to high-grade fibres if they want high data, fast data over long lengths of fibre. And so all too often we see these dreaded images and scenes shown on the right-hand side there of access ports and their side array can actually open up and new cable deployed at significant expense. So our MVP is a simple plug-and-play device that taps straight to the physical layer. It's transparent to the IT protocols currently used by IT managers. It can be deployed in an hour at 1/10 the cost of recabling an underground system, and indeed with minimal downtime. So a typical recabling job can actually take weeks to months with significant knock-on effect to the business activities of the stakeholders of those networks. And if I just quickly focus on the performance, so 2 kilometres of multi-mode fibre, which those sort of lengths do actually exist out there in public and business networks. 2 kilometres of fibre will normally only support 1 megabit per second of data. Our device supports 100G, and this is a value that's been tested by ARNet. So we're actually in a growth phase at the moment, growing sales and scaling up our production. And with that, thank you for your time.